I like now to introduce you Professor Rosamond Naylor. She is Professor of Environmental Earth Science at Stanford University, United States, and she is also Director of Stanford's Center on Food Security and Environment. So her focus is on researches on environmental and equity dimension of intensive food production, such as aquaculture and production high input aquacultures, development, climate-induced yield, variability, and food safety. So please, Professor Naylor.
Thank you. Thank you. It's a real pleasure to be here today. I've really enjoyed the discussions and the presentations so far, so I hope I can keep your attention. What I'd like to talk about today is aquaculture and its role in fisheries and the environment and food security. But before I get started, I just wanted to note that our Center on Food Security and the Environment at Stanford covers all of the topics we've dealt with today. We work a lot on agriculture, on livestock-based systems, on the economics and policy dimensions of agriculture. And in fact, a new book by Oxford University Press just published last month, The Evolving Sphere of Food Security, is now out. I only have one copy, so I didn't leave it in the back. But it puts together very much of an interdisciplinary viewpoint on how the challenges of food security really evolve over the course of development. And even countries like the United States have a fairly serious food security issue. So I think we all have interesting things to talk about in this room. I did leave some material about our center in the back. But I do work a lot on aquaculture. That's one of my leading areas of research. And so today I wanted to share some of my thoughts and get some of your reactions. I just want to start with a story. At least in the west coast of the United States, we have this love affair with salmon. I mean, they're the most amazing organism, just that they go out there and swim for a couple of years and come back to the exact same place and spawn. And they're so beautiful to watch, anybody who's gone into a stream and watched them. And we've been fascinated by salmon for quite a long time. And have, as a result of this, wanted to preserve salmon, have the ability not only to see them in the wild, but to eat them. They are so delicious and healthy for you. So actually hatcheries go back 100 years or so, and we've been fiddling around with the genetics of salmon for quite some time. But we're now moving towards aquaculture systems in a fairly major way. The one thing to note about the wild salmon is they come back and spawn, and they're typically caught in a very seasonal time of year. And so you're getting all of the catch at one time of year, and then would have to be frozen or just eaten at that time. Aquaculture really came in, not just hatcheries, but actually raising purely in captivity in the 70s, and really became economically viable in the 1980s. And University of Washington, some Norwegian scientists, I think, introduced this first commercially viable species, but Scottish producers were also involved in this technology. And by 1990, about 40% of the salmon that are in the markets was already from aquaculture. And today, over 3/4 of the salmon that we see in our markets is from aquaculture. And so this has really been a very booming industry. And booming so much that by the mid-2000s, Chile had adopted salmon aquaculture. There are no wild salmon in Chile, but they had taken on the technology and very intensively managed this with intensive in terms of the density in ponds, in terms of the antibiotics and so forth, and had a very major disease outbreak called ISA, infectious salmon anemia, in the mid-2000s, which really caused the entire industry in Chile to completely crash, and they are now rebuilding it. But I think it's one of those warnings of how fast to intensify, how to manage these systems environmentally and health-wise, as well as economically. So this was a big industry for Chile, and now they're just rebuilding. They had rivaled, actually, Norway in terms of total production at that time, and they're just gaining their market share back now. We have a project in Chile looking at the social impacts of all of this because, in fact, they had big food security impacts. This was grown in one of the poorest regions of Chile, down in Chiloé, and a lot of people were employed in the processing and in the industry, and within a year or two, really just lost their jobs, and it was a very serious economic dislocation at the time. So when we think about food security, our center and my own research deals with locations around the world, with aquaculture and with other commodities. And this is a picture of a woman carrying mud in Kenya where she's building a pond. But as we've talked already, the definitions, can we produce sufficient amounts of food, the availability question, and can we do that at a reasonable price so poor people can afford it? Can people have the physical and economic access? That is, do they earn enough incomes, which largely do come from agriculture, as we've talked about earlier today, to be able to afford food? And can we do this and still not destroy the environment in the process? And that's one of the center's goals, and my goals in particular. And then how nutrition is delivered is very important. I think that the food security field in the past had focused largely on calories. And it's very clear, as mentioned earlier today, that if we lack the basic nutrients, iron and other micronutrients, there's still serious malnourishment that can affect cognitive development, educational attainment, and so forth. So nutrition is important, and fish happen to be very nutritious. So what I want to do today is give you a very brief background and then talk about two case studies. One is in China, which is the major player, as I'll explain, and then go on to a poor, less developed country that's just beginning its aquaculture development in Kenya. So I'm going to feature my postdoc Ling Chow and on the right, Katrina Le Moyoy. I'm working with both of these very talented women in the field. And if I have time, I'll get to a new piece that we just had recently out in the proceedings of the National Academy of Sciences, just looking at whether aquaculture can enhance resilience of the overall food system or not. If I don't have time to get to that, we can talk about it in discussion or at dinner or over a drink. The basic issue here on the fish side, as we've mentioned before, we have gone from 1965, 3.3 billion people, now more than doubling that to about 7.2 to 7.3 billion today. And each of those people, the per capita consumption of fish has gone up from 9.5 kilograms to 19 kilograms, so doubling what each person eats on average and then doubling the overall population. So there's a huge demand for fish out there. And I want to take you through this one graph because it's actually quite important. What you see in the top line, the blue line, is the total wild capture fisheries, which has been pretty stable. This series begins in 1990, so it's been the past 25 years or so. Pretty stable at about around 90 million metric tons. The dotted line below that is actually the capture fisheries that goes into food uses. And that's been at about 61 million metric tons. Below that, in the purple line, is the non-food uses, the industrial food uses. And of that amount, that black dotted line is what we see in reduction fisheries, the fish that's ground up that goes into feeds, more or less. So we see all of that remaining fairly steady. This is the last of our food systems that we actually go out and hunt and gather. And it's amazing we're actually staying as steady as we have given the pressure on these systems. But there's huge pressure and many depleted fishery stocks out there. So meanwhile, aquaculture has been one of the proposed solutions, and certainly not only a solution for food security, but this is a very lucrative industry in a lot of ways. So people may say this is for food security, but there's a lot of money being made in this industry at the same time. We see with the green bars, it's an industry that in terms of volume has increased fivefold in the past 25 years. And I'll talk quite a bit about this process as we go on. But I want to point out now by that circle up above that in terms of the amount of fish produced for food, aquaculture is producing 1 in 2 fish that you have on your plate. So half of the fish is now coming from aquaculture that you are eating. And it's been a phenomenal growth, almost 8% per annum growth since 1990. That's way higher than any of the other food sectors. So this is really a sector that is on the move. Most of it is in Asia. 89% of aquaculture production is actually in Asia, which is in this big blue area down below. And the big blue area is China, and then the rest of Asia is in that rust color. So that's 89%, and very small amounts really for the rest. And China is what we would call what we say in the United States, the 800-pound gorilla. That's the guy that comes into the room that you can't quite ignore. You have to deal with the 800-pound gorilla, okay? So about 2/3 of global aquaculture production is coming from China. Now, a lot of this volume is in shell weight because they produce a lot of mollusks and other shellfish, but they have been farming fish for hundreds of years and have quite a track record that is really interesting, I think, to learn from. And they are very much on the move in terms of where this industry is heading. So when you look on the left, the top aquaculture producers by volume is on the left. That's China, 62%. Then you go down to India, which is less than 10%, and Vietnam, Indonesia. So all of them really pale in comparison. And I show this slide in the US because although we debate aquaculture a lot, we only have 0.6% of the global volume of aquaculture in the US, a lot of catfish in particular. By value, China is almost 50%. So what's really interesting, and we've been talking about diversity and resilience today, what's really interesting in aquaculture is that there's over 300 different species currently farmed around the world. And these from the left there would be shellfish, which do not require any feeds. They're just going to use the ambient nutrients from the water column. Up above, that's a carp pond in China. That's the traditional fish in a freshwater pond, and it can eat anything, basically. And it's often in layered and trophic levels, so it's feeding itself from waste of one fish to feed the other. To these shrimp ponds on the top right here, that's the coast of Thailand, which are carnivorous for the most part, that require fish in feeds. To tuna, which require about 15 pounds of fish for every pound of tuna that is farmed right now, to the salmon culture in the middle here. And so there's a huge range in different systems all over the world that is very important. But the feed issue is something that I'm going to talk about quite a bit today. But for those of you who are not as familiar with aquaculture, I wanted to give you a sense of just how industrialized this process has also become in certain parts of the world. And salmon is a great example of this. This is a high-valued marine salmon pond and farm up in Norway. And it's pumping these live fish for processors in January, meaning you can produce fish all year round every single day of the year. No longer have that seasonal constraint I mentioned before. And these ponds and activities tend to be controlled by large multinational companies, which would have computers showing the stocks and the growth and the maturity in all different parts of the world, and so they can just manage their inventory at any given part of the world. And then you can box this fresh salmon, so if you're buying fresh salmon in the market, if it doesn't say wild, it is certainly farmed. You're boxing it up and shipping it to Walmart, and the prices have come down for salmon a lot because of the scale, and so salmon has come into the diets of many people that never ate fish at all before, let alone salmon, and it's overnight would be fresh fish in the market. And even Walmart or Safeway, Carrefour's, you name your retailer, can really dictate what color they want their salmon to be every single day of the year. So 365 days of the year, I want dynamo red salmon, same cut, bones out. This is big progress in fish. No one has to cut bones. It looks homogeneous. It's not sort of a fish that gets thrown in the bottom of the boat and is kind of different color, and you don't have to deal with this. Chefs, people who want convenience can deal with this fish very quickly. And we even have now a genetically modified salmon that is being tested. It's not approved yet. It probably will be approved within the next 2 years in the United States. It's called the Aqua Advantage salmon. And the idea of this salmon, this is a measurement of our GMO salmon and a regular salmon, Atlantic salmon, that would be at the same period of growth. And so what this does is it takes the genes from a Chinook salmon, which is the largest Pacific salmon, and then a regulator gene from the ocean pout. And the gene from the ocean pout essentially turns on the hormone so that the hormone pumps 365 days a year, because most of the growth in salmon occurs during the warmer times of the year, and then the growth stalls out during the colder seasons. So with the ocean pout gene, this hormone will be on all year long. And so this salmon will mature in about 16 to 18 months, as opposed to twice as much, 31 to 36 months. So this will make you really uncomfortable, especially coming from Europe, but even coming from the United States. Do we want our animals being GMO animals? And the rationale behind this that's been totally tested for safety, human safety, no allergenic issues, and it has the terminator gene, so less than 1% or so of the genetic material would ever survive past one generation. There's still risks of this. People are uncomfortable with this. But on the other side of the equation, the feed cost would be much lower, 25% less over the cost of that lifetime, and you're going to get a lot more fish out of the system. So if we're worried about how much volume we're going to get to feed the world, you're going to get at a lower price here too, this is the kind of answer that's going to be popping up. Now, there's a lot of environmental risk in general. Genetically modified salmon is on the lower right here, but I'll just point out that a lot of new diseases and parasites can spread from these cages. Fish can escape from these pens and breed with the wild. There's a lot of predator issues. Certainly sewage that sinks to the bottom and causes pollution. There's a lot of fish meal and fish oil that are used in the process. So I'm going to talk about some of these issues today. One that we're familiar with everywhere where salmon is produced is these diseases like infectious salmon anemia that hit Chile, but sea lice, which is on the left-hand side, has really devastated the Canadian industry, but you see these lice in salmon virtually everywhere. Actually, they come from the wild salmon, but if they come into an aggregation where you have this huge density of fish that might be fairly stressed out, the lice can spread very, very rapidly and then go back to the wild in very large numbers. So this is from one of my students works a lot on tuna, and sharks just love these tuna pens. I mean, here is this huge volume of captive fish they can go after. So you're pulling out fairly large sharks and so forth. And one of the issues when aquaculture is actually in ocean environments is the theory is that dilution will be the solution, that you put these pens in areas of very high currents and just let all of those nutrients and chemicals and so forth wash out with the currents. So we've done work at Stanford where we're really asking the question on a given net pen, say for salmon or halibut or something, are these now the new feedlots of the sea? And I worked with some fluid dynamics specialists at Stanford to say, if you modeled these nutrient flows in a pond like this, and this is just an illustrative bay. It actually very much looks like the Monterey Bay close to us. And after 6 tidal cycles, the red would be more concentrated nutrients. You see that the nutrients don't flow out in a very Gaussian way. They aren't just distributed everywhere. They tend to adhere within currents and then have kind of a plume of pollution. Okay, so this would be after 6 tidal cycles. And after 60 tidal cycles, you're getting a very concentrated plume of the nutrients, and they're going all the way down shore. So if you have your nice beach house located down the shore from Monterey, you're not going to be very happy that the industry happened to be located there. And so these are all issues that the industry, just like the livestock industry, has to deal with. This would be a case of China, okay? So this is some marine aquaculture in Luoyang Bay in China. And we're starting to say, so China is starting to get very concerned. They have very high capita fish consumption. And as they are depleting their own fisheries, they are thinking aquaculture is definitely the solutions. And why not farm the oceans? Because then the rationale is then let the wild fisheries recover. But if you're actually having a situation like this, you're obviously disrupting a lot of the current and the dynamic flow in the system. Probably the recruitment of the wild fish is going to be very much limited in that case. And so we're working with a number of Chinese scientists now on the scale and the composition and where aquaculture is really heading. I do a lot of my work on the use of wild fish in feeds because aquaculture really is a solution to the depletion of wild fisheries. But if it depends on wild fish and feeds, it may not be. And so it really depends on what type of aquaculture you're looking at. We've been working on this since the 1990s. What we're seeing is we're fishing down the food web, so many more of the forage fish are the ones that we're fishing now, as I mentioned earlier. In general, we have a net positive fish in to fish out, meaning that you only need, like 8 pounds of fish in to get 10 pounds of fish out when you take into account all of these fish that we're producing that are fed, not shellfish here. But for some species, like salmon here, and salmon requires a lot of fish oil too, that's the omega-3 you're looking for. The blue lines are what we measured in 2000, the green lines are 2006, and this is really where the industry is making the most progress because this is a huge cost for the industry is the feeds, and they have huge incentives not to have a lot of waste, obviously. That's a big cost issue for them. But still, about 5 pounds of wild fish is used to produce 1 pound of farm salmon. And so still that ratio is not looking too good. Now we might ask, is fish in, fish out the right metric to be using, especially if those fish in maybe come from a processing plant. So I'm going to talk about that, but I wanted to give you the sense of the magnitude that what fish you're farming really does matter here. And I mentioned tuna is maybe 15 to 18 pounds of wild fish for every pound of farmed tuna that you're getting. It matters because the stocks of many of the forage fish are already depleted. They've been depleted or very stressed out for a number of years. If aquaculture really is going to grow and solve the demand for fish, it's really going to have to find its way around this fish meal question. We're not going to get much more out of these particular species and particular populations. So China is trying to do this also with filter feeders, so they don't need the feed inputs. But on the left, you see an oyster farm, and on the right, you see seaweed farms. But you can see the scale of which they're doing this to actually meet the demand has also some serious habitat and environmental consequences. And so this has to also be taken into account, even if the feed ratio is low. So I want to turn to China quickly, and China is just fascinating to me because it's the biggest in everything. It's the world's largest aquaculture producer, as I said. It's also the largest fish producer overall. It's grown 3 times since 1990. 70% of their fish actually come from aquaculture, which is much higher than anywhere else in the world. They also are the largest fish exporter. They're the largest fish processor, sometimes import fish, process, re-export. And so they process a lot of fish, both their own, some of their own, and they re-export a lot. They still have a taste for whole fish, but as the economy develops and incomes develops, they also want more processed fish. And as you know, fastest growing economy and changing consumer taste. So what about China? It's kind of overwhelming the world in a number of ways. We've had a large project trying to open up what I show here as this black box. Since 2009, we've been doing a lot of rural surveys in different places, just even for the carp and tilapia farms, so those farms that don't require fish meal and feeds, to find out, are they using fish meal? If so, how much are they using? And what are the other impacts in terms of the economics of these systems? And I should note too, Jerry Nelson mentioned he was an economist. Even though I'm in the Department of Environmental or System Science, I'm also trained as an economist. So I have this lens going through a lot of this today. So we've been working a lot in China, have published some of this work recently, and right now have engaged about 35 scientists in this area, both fisheries and aquaculture area. And we're having phenomenally interesting discussions in terms of managing aquaculture and fisheries as a whole for China's future demands. And so we'll have a new paper coming out, hopefully this fall from that, but much more work and interest for those of you who want to talk about it. But some of our work shows, for example, somebody mentioned statistics in China are often poor. China underestimates its seafood consumption by 20-35% because their official statistics and what FAO uses don't take into account out-of-home consumption. And when you don't take into account, you're really underestimating even what the demand is there. And when adjusted, the annual per capita consumption already is at 30 kilograms per capita. So remember, we said 19 for the world as a whole, so much higher than the world as a whole, and heading towards 50 kg per capita. So essentially, is China just going to sort of take the world's fisheries for its own aquaculture and for its own fish consumption? That's a big question that people have. What's interesting in this top graph on the left is when you look at the what fish they're producing, and in the back you won't be able to see as clearly, but almost all of it are different species of carp and tilapia, and that's making up almost all of it, and then some shellfish. Okay, so these are ones that don't require feeds. They're all in that circle here, that, you know, very little fish in to feed out. But they are using more fish meal in feeds so that they can have higher growth and be more commercially viable, and they're getting a higher rate of return by using some of these feeds now. And so even small inclusion, when you're looking at such large volumes in China, could really add up to a lot in terms of the global numbers. So China is by far the world's largest importer of fish meal currently, at about 1.2 million tons. One of my students put together this map. The dark red shows the largest imports. The dark blue shows the largest export. We have this line going from Peru to China, a pretty substantial anchovy feed line going there. The United States also supplies quite a bit of fish meal to China. And so it's interesting to just see its role globally. Of course, fish meal has been used in livestock feed as well, and that has been going down quite a bit with the aquaculture going up, which is in the blue. So I'm going to skip some of this because I'm going to be running out of time. One of the reasons why they're using these feeds in fish meal is because they are scarce in land and water, and they're having to put a lot of high-valued species in these ponds to actually make an economic profit. So when you look at a carp pond, it's actually filled with many other fish too. In fact, our survey found 31 different species of fish in these ponds, and so there's not really a carp feed conversion ratio out there. Just like anywhere else, water constraints on land and land constraints are really putting pressure on China. So as they source their fish meal, if you look from Peru, they're sourcing from a sustainable fishery. It's derived from a quota, and these quotas have this positive cycle of higher fish meal prices, better management, and so forth. But they also, for their low-valued fish, are sourcing from their own fisheries. And what they're doing is they're overfishing, they're getting less fish meal, higher prices, more fake fish meal, poorer quality. And so this is what's going into their systems right now. You can see trash fish, which is mainly juvenile species. About 32 to 50% of this fish comes from juvenile species of commercially viable fish. We've identified about 56 species of trash fish that are used in their feeds, and some of them are already overexploited. So this is kind of what it looks like, and what China does and what many Asian fisheries do is they don't have targeted fisheries for everything. Boats will go out, capture everything they can in their boat, put it on the shore, and then just sort it out. And this is them sorting it out, what goes to feed, what goes to food, and so forth. And so the depletion potential is very high. There are a number of other alternatives, and Ian and I were just talking about the other alternatives that are actually cheaper per pound of protein than anchovy meal at the bottom. These would come from poultry, feather meal, poultry meal. It might come from bone meal from other livestock products, that all the carcass waste, dry distiller grains from the biofuels, or from corn or soy gluten meal. So there's a lot of alternatives here. And China itself is now, because they're a large processor, we were calculating what could they do if they reprocess, or if they processed all of the processing waste into fish meal. How much could they save from importing and relying on wild fisheries, either domestically or internationally, if they actually had that processing capability that Ian was just talking about. And in fact, they could already, if they could deal with the food safety and the efficiency, could already supply over half of their fish meal needs by just using all their processing waste as fish meal. There's a lot of other alternatives, different marine proteins, microalgae, bacteria. These are interesting developments that provide omega-3s, but are still very expensive, not really to commercial scale yet. Polychaete worms would be another one, high protein, high omega-3s, but also new industry, hasn't reached the scale economy. There's other ones that we could talk about. And there's a lot of constraints, though. There's, using corn and gluten, there's a lot of fiber, and so a lot of waste that comes out, just feces that comes out of that. Often the amino acid mineral content will be low. Farm fish may not like to eat these different feeds, particularly the cereal feeds, if they're used to eating fish feeds or have been evolved to eat fish feeds. And then they have to worry about the omega-3 content, which is why many consumers are buying the feeds, because some of the grains don't have it, and some of the progress right now has been to actually genetically modify canola to have the long-chain fatty acid. A lot of consumers don't like that we're using genetic modification or bone meal in feeds for our fish. This is not always good. Obviously, we have to deal with food safety issues, and there's lots of economic constraints. These are fish that are eating fish meal on the left, which they love. They don't really like the soy pellets quite as much. And I think I'll just end here. I could go much further, but we talk a lot about the different alternatives in terms of solving some of these problems in the feed inputs, but we could also farm at these lower trophic levels and integrated farming systems, which would really help not have the need for fish at all, and source from sustainable fisheries. I'll just note that science can help determine the most sustainable, but economics is really important here. And yeah, I think I'll just end with that, and I can tell other stories about Kenya if there's questions. So thank you.
Thank you very much for your presentation, Professor Naylor. And please, are there any questions? Yes, please.
In Switzerland, we have mainly aquaculture with rainbow trouts. And now they start with pike perch. Do you have any experience about pike perch?
I haven't worked in perch at all, actually. But I know rainbow trout is a very, very widely farmed species, and perch, as I said, with 300 species, there's experiments going on in so many species, and the issues often, it's not easy to raise a fish, and so as we're converting these systems for food security, particularly for the poor, there's a large experimental period in terms of how these fish will survive, what the inputs that will be needed are, especially fish meal, but what the diseases and pathogen load is going to be. And I would suspect those are going to be the biggest challenges up front on the perch. But perch has such a large market, I'm sure there's a lot of investment in it. I just haven't worked in it.
Rosamond, I have two questions for you. Number one is, can you draw a picture where we will be in 2030, which is in 15 years, in terms of fish as food, either from plants or from the seas? And the second question is, what type of innovation do you think is necessary and investments to make your vision about 2030 and fish as food possible?
Yeah, great question. So if I go to 2030, I definitely think the most progress is going to be made on the feed side of things, bringing the what we can call inclusion rates of fish meal and fish oil down in the diets. And already the industry has made huge progress in this area. There are challenges like I talked about. One, when fish don't eat fish meal, they don't taste that fishy. And so we as consumers are going to be eating kind of like a hamburger. Okay, it's going to be higher in omega-6s and less in omega-3s unless we have the genetic modification. So there's trade-offs we're going to make here, but I think it's going to be brought down a lot. Now, the really cool innovations, I think, are on some of these microalgae areas and single-cell areas that have the omega-3s. They're expensive right now. They're expensive, especially in terms of their energy inputs in the production and trying to scale these up. But I think a lot of work is on the algae side, and actually Ian and I were talking about this. He might even be able to say something about what his company is doing on this. So I think that's a very promising area to bring some of the technology down. And in some cases, you can bring it down in conjunction with another industry. For example, with the biofuels industry, there's certain technology compatibilities between biofuels, actually, and these algae that might help in sort of a joint research, upstream research mode to make these products available sooner at a cost that's affordable. So those are the really interesting ones. Now, the one I'm focused on in China is just recycling all this waste that we have in our animal-based diets. So we've talked about how many animal products we eat, and like it or not, we should reuse this in our feeds. Now, there's food safety considerations that really need to be put first and foremost in this, but those can be overcome and have been overcome to a large extent. Already China uses about 40% of its processing waste, fish processing waste, as fish meal. And these plants are old and decrepit, and we need an innovation challenge to just, that's one of his guys could just figure this out and pop these things up all over the place, and it would really make the difference of saving the oceans. So I think that's a huge one. And you think about that's kind of self-sustaining because you're producing more and more aquaculture product and you're getting the processing waste from that and just putting it back into the feeds. It would be a sustainable design, as the optimist that I am.
Banne Würzburg, are there any quality control processes in place? What amounts of phosphate or antibiotics are added to this fish?
There are different criteria in Europe as well as in the United States, and so the nutrients, the phosphorus and nitrogen, would be non-point source pollution, and so that's very difficult to regulate actually in the United States, and it's not done particularly well. I don't know how well it's done in Europe, but there are regulations around it. In terms of antibiotics, the way they regulate it mostly is regulating antibiotics that would have conference to human, resistance, and so, but they don't necessarily, every country has a different set of regulations. Chile put on more inspection after their crash because that was largely, they were using so many antibiotics that the fish were all resistant to everything, and when the disease came in, they just all died. So they have become much more careful, and I think the Chilean experience made a lot of highly commercial visible fish farmers more worried about it. But when I wander around the farms in China, for example, I mean, they're throwing in random, I can't tell you exactly what's in all of this feed that they're using, but there's definitely antibiotics in a lot of it, and I don't think it's regulated as well. China is very worried about their food safety, and so any fish, for example, the United States is the largest importer of their tilapia. Those fish are highly regulated, but the carp that are going into the local markets or the tilapia, I think, that are going into the Chinese markets are less well regulated. So It's a process, yeah, it's a good question. And it is, when you're eating farm fish, you're not gonna know completely what you're getting, yeah, unless you know the producer and it's branded in a certain way that you know is right.
One last question, please. Yes.
Hi, Professor. Thank you for sharing this great Chinese case. I come from Chinese Academy of Agricultural Sciences. I know very little about fishery industry, but I'm curious about, you mentioned about consumption of fish in China. Now is 30 kilograms per year in average. But here I want to share with you a kind of information that actually the fish consumption in China is totally uneven, and for the 12 provinces in West China, the average level is just 7 kilograms, and we also do a kind of household survey in multiple provinces of West China, and we found that less than 13% of households eat fish in a whole month. So I'm curious about your project in Fujian province. Is there also consider some way to let the people from West China to get access to the fish food and by processing or by some other ways?
Yeah, I'm so glad you mentioned this because you're letting me give a little bit of the last part of my talk I didn't get to. So you're right, when you average on China, you're going to get this incredible distribution. And China itself has an income distribution that is really skewed now. I mean, the inequality, the Gini ratio is above 50 now. It's much more unequal. And so obviously in the East, you're going to get much higher consumption than in the West. The project that she mentioned was one that we have on micronutrients identifying malnutrition in West China, which is very, very widespread because it's a calorie-based system. A lot of the farming households and children going to these schools don't get anything but base calories and don't have iron and other micronutrients. And actually, the Chinese government is thinking of expanding tilapia systems to those areas as a means to deal with the food security, which is great. So it has to be in an area where there's water availability and so forth. But what we're learning in in Kenya, just as a highlight, is it's not easy to transfer aquaculture technologies to populations that have never raised a fish. China's so successful in aquaculture because they've been farming it for, centuries. But for those that have never farmed a fish, it's a risky business. Those fish don't always live. Farming households don't always know what feed inputs to put in, and the fish die. And so their risk assessment, extension workers may think, poor people are poor because they have a mindset of being poor. Well, really, poor people are very rational. They're just very risk averse because they're on the edge of life and death. And so we're finding in Kenya, for example, farmers that know how to raise chickens very well or corn abandon their farms quite quickly because they just don't really know how to do it. They don't see where the markets are, how it all fits together. So there may need to be, on my last point I'll make today, in many cases, kind of a pioneering innovation strategy where you get more successful or larger scale kind of operations in there to pioneer, get some of the supply chains in place, and be able to have some knowledge base there to spread to others in Western China. So Western China is a really interesting case. The Chinese government's particularly interested in educational attainment because the malnutrition is so high, kids aren't learning in school anymore. So very challenging in even successful countries like China. So thank you all very much.
Thank you very much, Professor.